Okay, let's talk about how we find the distance between 2 points on a straight line, one of these linear equations. And what can we do with them? All right, I have been given 2 points, negative 3, 1 and 3, 4. When we graph it, it looks just like that. Now I've kind of kept this really simple. If we imagine if we had to find the slope of this thing, what would we do? Okay, well, we would consider the rise. So this is the change in the y-axis, and we would consider the run, which is the change in the x-axis. And funnily enough, that kind of looks like a shape that we've worked with quite often. It looks a lot like a right-angled triangle. Now we know how to find the distance of a hypotenuse, this side right here, in a right-angled triangle. We just need some Pythagoras' theorem, which is right here. A squared plus b squared equals c squared. Now, when we're dealing with these Cartesian planes, we don't necessarily have an A side and a B side, but we do have sides that have a name. We know that this is called the rise and this is called the run. So if we say that instead of A, we'll call that the rise, instead of B, we'll call that the run, well, our formula looks a lot like this. It looks like the rise squared plus the run squared. Now, based on our previous work where we were finding the value of m, we know how to find the actual length of the rise and the actual length of the run. And we do that by using y2 take y1 and x2 take x1. So in this instance then, we know that the square of the side of the hypotenuse, or c here, it is equivalent to the run squared and the rise squared. We can write this a little more succinctly by saying that the distance, which is the c side, right? That's, well, not like you go to the beach, but it's the side that is c, it's the hypotenuse. Normally we would call that d instead, because it's the distance, right? That is the distance between the 2 points that are on the straight line that we are looking at. And I'll take this little thing out because we don't need that there. So when we put it all together, our formula looks just like this. The square root of y2 take y1 squared plus x2 take x1 squared is equal to d, which is the distance of that line. Okay, so let's work that out specifically for this particular one. All right, I'll move all this up. I'll leave that there just so we can remember it. Here's our 2 points. I've got my negative 3, 1 and my 3, 4. I do need to give them a label. I'm going to call the first pairs x1, y1, the second pair x2, y2. I'm then going to use this formula right here. Now, just for the sake of the argument, I'm just going to pretend that this is the formula that I've written down just before I start to work stuff out, right? I'm going to call that my C and, oh, not C, D. I'm going to just quickly write down the numbers. I'm just going to substitute. There it is. Substitute it in the numbers that I wanted. My x2 take my x1, my y2 take my y1, and I can then work these things out. 4 minus 1 is 3, 3 minus negative 3 is 6, so that's what the next bit looks like. I can then work out those bits, I can square them, add them together. Now, I do want to make a note, and I have showed in the past that we can simplify surds. That's what these are. The fancy name for them is a surd. That didn't quite work. So we can bring that down into a lowest form by finding a square number that's a factor of this. We do have a square number that's a factor of this. It would be 9. So 9 is our an answer. We can find an answer to that. Square root of 9 is actually 3. And so our answer, perfectly right, for our distance would be 3 root 5. That's our distance. But we can round that off as well. We can say that it's approximately 6.71. And what you'd need to say is that this is correct to 2 spaces, or places is probably a better word, 2 places. Correct to 2 places. Okay, so that's how you do it. That's how you find the distance between 2 points. Okay, try to give me answers in both. Try to give me the most accurate surd as well as an approximation, unless, of course, the question's asking you for something specific. In that case, do as you're asked.